All right, this video is going to be over trigonometric integrals, which means that you have trig functions inside your integral. We are mostly going to be focused on integrals with sines and cosines, and there are some rules that you might want to just take note of. When we have sines and cosines to powers, if sine is the one that is odd, then rewrite it so that it has an even that's 1 degree lower times sine. We'll use the identity here to rewrite in terms of cosine, and then the derivative of cosine is your sine piece there, so we'll use a u sub. Similarly, if cosine is the odd power, you're going to do very similar steps. Okay, if they're both even, then we might have to do something kind of fancy where we use a double angle identity, kind of rewritten so that the double angle's over here, and then your sine squared and your cosine squared is here. But we'll look at how to do that and multiply through appropriately. All right, our first example, notice that they are both odd, so we're going to go with the one that has the power. So cosine cubed is one we're going to be looking at, and the derivative of cosine is sine, and I just have 1 power of sine, so I can actually go right ahead and just do this as a u sub. U equals cosine x, du equals negative sine x dx. I have that here, so I'm going to just move that over, and so I can rewrite this as u cubed and then negative du in place of sine x dx. Well, the antiderivative then is negative 1/4 u to the 4th plus c, and I can plug back in, and this would be cosine to the 4th x plus c, and negative there. All right, let's look at something like example number 2. So if we have cosine squared and then sine cubed, we want to rewrite this so that there is just 1 sine. I'm going to then rewrite sine squared in terms of cosine, and then I'll be able to do something very similar that we just did. So I'm going to rewrite sine cubed into sine squared times sine. And then in place of sine squared, I'm going to write 1 minus cosine squared from the Pythagorean identity. That gives me cosine squared, 1 minus cosine squared, times sine of x dx. If I distribute here, I still have to keep that sine of x dx. So think of this almost as distributing actually cosine squared sine of x, like moving this together and then distributing that inside. So I'm looking at the integral of times 1 cosine squared sine of x minus cosine to the 4th sine of x dx. I'm going to do the same u sub that I did, where I'm going to let u be equal to cosine, and so du equals negative sine x dx. That means here I get a replacement of sine and dx, so I'm going to get negative u squared. I have a negative here, so plus u to the 4th du. And so I get negative 1/3 u cubed, so cosine cubed, plus 1/5 cosine to the 5th plus c. All right, let's keep looking at some examples. So here I just have a sine squared. I don't have a cosine, which might cause some issues. I need to have like the du part of this, right? So I'm going to replace sine squared with the identity 1/2 minus 1/2 cosine of 2x dx. Okay, the double angle identity is cosine of 2x is 2 sine squared x minus 1. And so if you solve that for our piece here, or excuse me, if you solve that for this piece here, you end up getting that sine squared is this piece. Okay, I think it's plus one to get the minus on the other side. Anyway, but this is our integral that we are now going to be looking at. So antiderivative of 1/2 is 1/2 x. Antiderivative right here, now this inside piece is linear, so I can take the antiderivative like I would with a u sub, but you can kind of do that in your head, like u is 2x, so du is 2dx. And so I have a 1/2 here. I'm going to have another 1/2 that I need. So minus 1/4 sine of 2x plus c. All right, let's look at another example here. This one does have secant and tangent in it. So let's just look at what we might need to do if you have something like this. Now, remember that the derivative of tangent is secant squared, and the derivative of secant is secant tangent. So I don't think I'm going to be able to rewrite secant to the 5th power as something that's just secant squared. Oops. Sorry about that, y'all. That like totally messed up. As something that is just secant squared. Like I can't rewrite that. So instead, I'm going to rewrite secant tangent, and then I'm going to be able to do a u sub here. So integral of secant to the 4th times secant x tangent x. And when I do that, I'm going to say let u be equal to secant x, so that du is secant x tangent x dx, and that's exactly what I have here. So I'm going to rewrite that as the integral of u to the 4th du, which is 1/5 u to the 5th, so secant to the 5th plus c.